Hi, I'm Alex Thomas, the principal data scientist here at Wisecube.
Hello, I'm Alin Blidisel. I'm the platform lead here at Wisecube.
Thank you for joining us for our webinar today. We're going to be going over our product Pythia, some of its methodology, and how to integrate it into your system. Let's see, let's get this. Is Akari? Oh, there. Sorry, we'll have to edit this part out. Okay. Let's see. This is our team here at Wisecube. We've been working together on mostly health science related stuff, but we've worked on a number of domains, both individually and as a company. Yeah, we wanted to talk a little bit about the problem with where AI is right now. Obviously, LLMs are such a huge breakthrough, but they also have a lot of problems, and part of the problems are a result of how good the quality of the text that they produce. So there's a problem with it being able to easily spread false information and mislead people, and even perpetuate biases that are either in the data or biases presented by users to the LLM. So there's this problem of hallucinations, and it's basically where the LLM is producing quality appearing content, but this content is false or not fully correct. So we need to figure out how to deal with that with AI. So if we don't, we have issues where where not only can we just output incorrect information, but it can also cost companies a lot of money and even put people in danger. So, for example, there's one case in Air Canada where the AI that they were using hallucinated a refund policy, and then Air Canada was forced to abide by that policy. And then we have a bunch of other examples here where the AI can very easily produce very bad results. And of course, whenever you have a problem like this, when these LLMs are being used in more and more places, the thing that's going to come next is going to be the regulations. But before the regulations, we still have this huge cost, right? So we have brand damage. We have the danger from specific things in highly regulated or highly sensitive fields, like, for example, in healthcare misdiagnoses or legal errors. So with these hallucinations, there's been a couple of things done to try and solve them. Some have tried to solve them by purely through prompt engineering. And maybe that can improve it somewhat, but it still has that risk there. There's another solution here where we're talking about RAG, so that's retrieval-augmented generation, and that's where you're giving the LLM some context to try and limit its creativity. But that doesn't always solve it too. It can still hallucinate off of the data given to it, the augmented data given to it through RAG. And really, the quality then just is sort of moved from depending on the LLM to depending on the data that you're providing it. So with Pythia, what we wanted to do is to figure out, how can we make people aware of their quality and give them actionable information that they can use to improve their system. So a big part of what we're doing is extracting these claims. So we want to really get that to understanding the factual elements of the text that's being produced, and that allows us to do a lot of really cool things. So it lets us improve accuracy over time and tailor the monitoring to your system. You can look at these. You can look at these claims. You can look at these results instead of having just like a black box metric or some system that only we only know how well it performs on a benchmark. So by doing this monitoring, you get reliability. You get to know how your system's doing over time. this can be done in ways that are cost efficient, so that you're not like spending too much on doing these extra checks. And if you compare this to like the other options that are frequently done nowadays, where you have either some sort of very rudimentary check, which will often be insufficient to actually give you the reliability, or you need to have a large manual labeling operation in order to label for your particular problem, and that's going to be very expensive. Because if you're working in one of these sensitive fields, generally just a random person will not have sufficient skills. You'll have to pay someone with sufficient background in that domain to actually label what you're producing. And another problem with that the human-based labeling task is that's not scalable. It gets really expensive once you start wanting to deal with millions of potential examples. And as I said, like the regulations are coming, and so if you want to be able to be ready for these regulations, you want to have a system that lets you understand what's going on from your LLM. And then what we're doing is that we're not just giving you just a score, we're giving you the ability to have to like run the score, get the claims, run other validators to give you real insights into your system. So let's talk a little bit about the methodology behind Pythia. So first, let's talk about the usage scenarios. We're breaking it down into sort of three types. There's a zero context. This is just open question and answering. So your users are just asking your LLM-based system questions, and they get responses. No like inherent documents are being no documents are being used to like augment the generation. The next one is this RAG, this retrieval-augmented generation. That's where the user gives some sort of input, some sort of question, and that's used to retrieve documents. And then the answer is in some way when the prompt is constrained with those documents. And then the third one is where the input is much more constrained to the context provided. So, for example, an example of this would be like of these three would be with open question answering. It might be something like very general, like, oh, what are some what medications might interact with this prescribed medication for me? So if you ask it to open question answering, it's going to depend purely on what the LLM has learned. With a RAG-based system, you'll take that question and search for documents and probably get a bunch of documents related to the different medications. And then the LLM will be asked to answer that question from these lists of documents. And then you have summarization here. And the question in summarization is really kind of optional. So you have like some sort of information, let's say about that prescribed drug, but it's like a lot of text, and maybe the patient can't fully understand all text, maybe it's too technical. So you have it generate a summary, and then if you want, you can guide that summary with a particular question, like, oh, summarize the like the interactions mentioned in the documentation for that drug. So these scenarios sort of set up what you might want to test, and the testing at a certain like abstract level can be the same, but some of the details of like how you might want to interpret the data will be different. But Pythia supports all three of these examples. So the first step, as I mentioned before, we want to extract these claims. A lot of existing methods, they work on either sentence level or on the entire text or chunks of text. And whereas that can work, that can get good scores on like the benchmarks. It's a black box approach. So you get these results that says, oh, this is good generated text, or this is bad generated text, and you don't really have much to work with from that. And that means that you don't know how it actually works on your problems, whether that system is actually a good measure, and you also don't get a lot of actionable information back. Pythia extracts these triples. So these triples are subject, predicate, object. We see some examples down here. So like patient has diagnosis, type 2 diabetes. So that's in the sentence above, that's the NIDM. So we have the patient sort of implicit in the sentence, and they have a history of, so that's going to give like they have a diagnosis of, and NIDM there is type 2 diabetes. And these claims serve as sort of like a breaking down of what's in the generated text and in the reference text, so that you can compare these actual claims being made. And it gives a very fine-grained analysis of your generated texts. So then once we have these claims out, we want to categorize them. So the categories are going to be dependent on which data set which part of the data they're in. So if it's in the references, but not in the response, that's missing. Usually that's not a problem. It depends. So for example, in summarization, there will necessarily be some missing claims because you are summarizing. So you're not going to necessarily have all the detail of the reference. But then we have the ones where they sort of share the fact in common, but they may contradict on what the actual fact is. So, for example, in the drug interaction example I used before, so this would be a case of maybe the document says that a drug is safe, but maybe the LM hallucinated that there is a negative interaction, in which case we'd mark that with the red X. If it marked it as it did say like, oh, there is no interaction with like this thing, we would mark that with the check mark. That would be an entailment. So entailment means that the claim is shared between the references and the response, and it's supported in the references. A contradiction is where the matter of the fact is referenced in both, but what's claimed in the response is not supported in the references. It's a matter of fact refuted. Neutral is where it's something in the response that's not supported or refuted by the references. So there doesn't appear to be an overlap in it. So the hallucinations will be in the contradictions and the neutrals. Most of the time, the neutrals are maybe less dangerous, but they're also very difficult to check unless you have another external data source. So when we compute our accuracy metric, we basically use a weighted harmonic sum of the rates of entailment, contradiction, and reliability. And actually, you might notice here it's like 1 minus a contradiction rate. So it's really sort of like the weighted harmonic mean of entailment, non-contradiction, and reliability. And this really gives us sort of like an understanding of how good the system's working. But you can also come up with task-specific metrics. So, for example, you can understand by looking at a schema for the triples that are extracted, you can determine what entities and what relationships are relevant to your task or more relevant to your task. And then you can weight those things stronger so that maybe understanding like aliases of the drug is not as important of a thing as understanding interactions for a drug. So you want to weight this interaction relationship much higher than aliases. And then you can also try and see like how well something answers the question. So you can measure a generative response against a question with a BERT model, and that really then sort of opens up to you want to have a good variety of validators you can use. So there's ones here. This is an example like detecting prompt injection. You want to have that on your input. Detecting toxic language. So you want to make sure that that your LLM is not saying something that's going to embarrass or harm your brand. And by having these things in there, not only do you have a system that lets you just measure over time, but it can also potentially give you something that you can react to. So if something triggers an improper tone, so let's say you want to make sure it has a financial tone to it. Improper tone, you could perhaps not let that result go out, or perhaps regenerate the result. You can take action before it's caused a problem. And so with all these things that you're checking, you also want to be able to monitor it over time. And that's a big part of like of what Pythia does. Unless you do these checks, unless you do this accuracy measurement, unless you monitor it over time to make sure that your system's not having some sort of deviation problem. So with that, I think I will hand it over to Alin.
Hello. Yeah, so right now Alex has presented very well exactly how Pythia works, what's the back end of the Pythia and how Pythia was integrated and how all the things and the features were created and what is the basic for everything that was integrated. And right now we will see Pythia in action. So as the first, I would like only to present exactly the main responsibilities that Pythia has introduced and will take care of. Like it will take care of the real-time hallucination detection and what it's using somehow like to detect that. It's like as the main part is the knowledge graph, and also to make sure that it can expose and also help the users to understand exactly where are the problems and how to identify and to take action, the continuous monitoring and the alerting piece. And with that in mind, okay, we can identify here the high level flow. So Alex has explained and went through each of these steps here independently, but I want to present somehow like a high level flow of the Pythia functionality and how Pythia works. Since Alex, our data scientist, has built all the magic, we have tried to expose and make that magic happen on the front end and also on the services layer. And with this in mind, so we can see on the left side like the RAG integration and the user input that the user will try to come up with a question, and then basically to search and to query the RAG for some references, and then based on that response from the RAG, then Pythia will be called for fact checking, and basically also the response and also the references are sent to Pythia for extraction. In one case, claim extraction, and in other, it's a claim comparison. And based on that, we will obtain metrics and a report that will help us to identify how accurate and how clear the response from the LLM RAG is done. And then as a very helpful tool, we have that online monitoring. In them, we can go to a app page, UI page, and then we can see exactly all the calls and all the alerts, all the metrics that are created for each independent request, or also for all the queries together. And then in some cases, if we decide that we would need to be alerted whenever we have something detected that it's not that we want, like validators type or some accuracy that is lower than a given threshold, then we can also be notified by an email. Okay, and here we can see very clear how Pythia works and what all the steps are in the integration plan. And basically on the left side where we see the AI client application, this one it has like 3 parts. In them, it's like the SDK, the GraphQL API, it's the Python SDK, then the library that can be installed directly with pip, and then is the GraphQL API, and also a UI application. In them, user can interact and see results. Then as steps in order to use Pythia, it's like, as we already mentioned, like responses and reference from the RAG. Then on the backend side and on the Pythia tool, the triples will be extracted, as Alex mentioned, the subject, predicate, and object of the claims. Then when we see how triples are built, it's like you see that checker module. In them, it's NLI, LLM, and also knowledge graph. So in that case, we are checking against the knowledge graph and we are building that claims. And based on that results, metrics are generated, in last situation, if the user decide that he wants to be alerted, he can also obtain alerts. And with all of this, Pythia, it's coming back and expose to the user the classified 3% metrics. Okay, and now it comes to the cool part. In them, we would have like a demo by using a collab notebook. In them, I would present exactly how all the things are integrated, how we install the library, how we make the things run, and how we can check Pythia against our own created reg system. And first of all, I want to explain shortly that our talented data scientist has successfully developed Pythia, and he has made it into a way in them it can handle hallucinations. But then all the advanced hallucination detection model and all this part that was integrated and the logic and stuff needs to be somehow like then interpret into a way in them it can be used and someone else can benefit of that cool hallucination detection mechanism. And basically it treats like various complex patterns and situations that can cause hallucination in human perception, and also it's clear that it will provide valuable insights after you will have like a clear picture of the responses that the reg will give you. So after we had this careful and strategic development, our development team, with me guiding them, we have integrated Pythia into our system, making it accessible and optimized for practical applications. So basically, we have engineered the integration in 3 distinct ways, and this is one of the way that we have done, like by using the Python SDK library that we have offered through the Wisecube platform. So it's a direct integration. So Pythia is integrated directly with our core service, and it's allowing the users to benefit from hallucination detection seamlessly within our main product. So API, it's integrated, and we wrapped Pythia in a robust and intuitive API, allowing the developers to utilize within their own applications, extending its benefits to a wider range of products and use cases. So, and also another step in them that can use it is like standalone applications. Like Pythia can also exist as a standalone application, allowing like a specialized and granular control over the functionality and cool settings that it has. So basically, these are the ways in them Pythia can be implemented. And the one that we have picked today was the one with the Python library from Wisecube. And basically what we need in order to start with, it's like these 2 libraries, the Wisecube internal library and the OpenAI library. And basically after installing that libraries, the next part is to obtain an API key, and to do that, you only need to sign up for free as a free trial to app.pythia.ai, and after you have the account configured and everything is working well, you have a section where you have API keys, and you can grab directly your API key from here, go to the notebook and use that API key further for implementation. And after the Pythia key is initialized, then the Wisecube SDK can be used and initialized. And for this particular scope for today, we have used the output format as JSON. But in cases that developers want to play with the data directly in the notebook and want to use pandas for a better usage, there is also the possibility to use, instead of JSON, the output format as pandas, and then everything works with data frames, and it's it's clear integrated on that. Okay, so with this section here, the Wisecube client is initialized and can be used. Then for the next part, we have picked some BOASK questions that we will use further in our into our demo to call our internal RAG system that we have built. And basically, in the following section, we will undertake the task of leveraging the power of the RAG and also OpenAI as a large language model, and to answer a series of questions by using a simple prompt from OpenAI. And here is the prompt and the initialization of a prompt. So a simple prompt. In them, it will has like 3 simple steps to get the context that we will get from the RAG and the question. And in some real scenarios, it can be the case that also the answer can be provided, but the answer is the one that we want to get as a summarized from the context and the question that the OpenAI can build based on the definition that we have created below. So in the next step, we have a simple method that is doing the OpenAI initialization by using the latest LLM model developed and deployed by GPT-4o, and we have used the GPT-4o mini to see exactly how it acts and how it works and how it builds the summarization and the answer based on the context that it gets from a RAG system. And basically, after we have all of this initialized and also set up an OpenAI AI key to be able to call the OpenAI and to get some benefit of the ChatGPT. In the next section, we will describe what is our methodology to obtain performance from the RAG and also OpenAI, and also to see exactly how this can ask a set of questions based on a contest of questions. And basically, we have here like the ability of the AI models to generate accurate, reliable, and contextual approach answers to complex queries within a given domain by getting some context from our RAG system. But in a way, we would see that besides of having like a clear RAG that it's built with embeddings and with a nice way of searching it and to get like a clear context back, in some cases we would see that the claims that will be generated by Pythia would be like either neutrals, either contradiction in some weird scenarios. But keep in mind that the current RAG system that we are testing against, that it's in our internal Wisecube environment, it's built based on embeddings and also based on clinical data. So we are using like 3-4 different indexes with clinical trials with data from PubMed, data from adverse events. So this is how this is built on, and everything is working based on clear embeddings and on semantic search. And if we move to the next step, we would see that what we have here is like a method that we have called like validating the RAG, and this is like validating the RAG and also the OpenAI. So what we have, how we have proceed with that. So in order to validate the RAG and to get something out of it, so it's like we have used the Wisecube client to get some documents based on the question. So that will give us a list of documents based on the questions and on the embeddings that are created directly as a semantic search against our backend service. And then from that documents, we are obtaining the answers, and then from the answers we are extracting the abstracts of the documents. That abstract, it's like the large text and explanation for each document as better as it can from the source. And then with that abstract, we are creating the context for the call to OpenAI. And basically the OpenAI call is done with that context. And I will just show below exactly how a context will look like, how a question, and also how a reduced context with the abstracts will look like. So in this case, we have the OpenAI response, and after we have the OpenAI response, we don't know for sure exactly how reliable it is, how accurate it is. We can only say, okay, we have obtained a response and we can expose it, but we are not sure if that's accurate or not. And to validate that aspect, here is Pythia. In them, we are calling Pythia with the reduced context, with the open API response, and with the question. So in addition, besides what we have called to OpenAI, we are also adding the OpenAI response. And with that in mind, this would be the final response. In them, we will see like the claims that Alex presented previously. And let's move on to a simple example. I already have run here to not wait in the demo for the examples, because this, as Alex mentioned, this is a rough process. In them, validators need to take in action and also to prepare the claims and so on. This takes like several seconds to proceed, and in order to make sure that we have everything here and in the collab and the notebook will not stop. So I have already run it before the demo, and we see here like this is a question, a BioOS question, and these are the context documents that we receive from our index, from our semantic search. And basically this is one type of an abstract that can exist into our documents. So based on this question, this is an abstract that can come from one of the documents that we have inside our X system. And depending on the clear information that can exist on the X system, this is how OpenAI will generate like a response and a clear response to our question. And then in order to trust this response, we are calling Pythia, and basically we get a list of claims. And let's jump here to that section, because we have here the metrics. And as we see here, so we have asked a question, and based on the question, we have obtained several claims back. And here are like subjects, predicates, and objects for all these claims. And as you see here, like by the classification, in the classification section, all of the classification is set to neutral. So that means that Pythia has identified that based on the context and the question and the response that the OpenAI has given, and also the context from the reg, it is not clear the response. And basically that means that we have a clear neutral here on that question. That means that it has to be investigated, and that needs to be checked, that because the accuracy in that case it's completely zero and everything is neutral. If we go to question number two, it's another BOS question to list all signaling molecules that interact with the receptor EGFR. And as we see here, as I also explained previously, we have context, we have list of document that we have retrieved, and then abstracts as context from each document that we have received. And basically, I want to point here that we are also trying to expose the top 10 results from our reg that are matching this type of question. And then with that question, we are going again to OpenAI to get a clear response. And then with the response, the context, and the question, we are using Pythia to see exactly how the claim classification is done. And as we see for question number 2, we can see that in that case, Pythia has identified 3 entailments. That means that whatever context and response we have obtained from OpenAI, it looks confident and it looks like it is like a legit response that makes sense, and it doesn't need to be validated anymore. So it's like a 100% validated. We see the accuracy, and then we have the metrics. Okay, another question with a different behavior. It's like question number 9 from the list, and in this case we can see again the abstracts of the question, the OpenAI response, and then the Pythia response. And if we take a look here at the metrics, because this is what matters, we see that in this case we have 3 entailments and 1 second. It was 1 neutral. The neutral, yeah, it looks like it disappeared from the list, but there is 1 neutral. If we take a look here at the top, there is 1 neutral. 1 second. So the claim, we see the entailment, and here is the neutral. 1 second. Entailment. Yes. Okay, let's jump here. And basically here it means that, yeah, we are very close. We have only one particular response that has come as a neutral. Everything else it's accurate and everything works well. So as we see, we have like this metrics that we can obtain from the results, from the claim extraction and from the classification of the claims. And another thing is, like, based on all the results, we can build like an average accuracy to see exactly how well the RAG and also the OpenAI LLM. Instead of the OpenAI, you can use like a internal LLM that can be built on that, and you can validate your internal LLM against with Pythia and all these parts. So basically, we can have also the global metrics with the entailment, with the natural accuracy, and in this case, we see that whatever was run on the internal RAG system with embeddings and that was built for that particular scope, we have not get any contradiction. But in order to expose also this behavior, we have created here another use case that it's calling like Wikipedia database for that. And basically what we have here is like we have collected some context from Wikipedia related to diabetes. Then we have added a question, like a gibberish question for that. And then we have tried, okay, let's use OpenAI to call with some gibberish question and some clear context related to diabetes. And basically what we get here from OpenAI is like a response based on the context that we have add and on the question that we asked. And if we use that information to check against Pythia, then we would see that we have a low accuracy, and also we get contradictions in that case, as we see here. 1 second. It's yeah. So basically, as we see here in that case, we have like claims, and basically here is like, yeah, as class as contradiction, then again class as contradiction, and there is only one claim that was identified as entailment from this gibberish question and nice context directly from Wikipedia. So the RAG system needs to be like validated in order to make sure that it can act well and it can not provide hallucinations. And to go further and also expose what Alex has added into the presentation, I would like also to go through the app and expose exactly all the calls that were done to the Pythia API can be seen and also can be checked against the UI and the validators that were used. So there are a lot of statistics that are available on the UI for the class for the classification of the claims, and then also how many detections were flagged by the validators. Then there is also the possibility to check directly based on some context and some LLM response, Pythia API directly, and get some responses back out of the box directly on the UI front end. And this is exactly how this will expose the claims with subject, predicates, and object, and what type of class it is, in exactly the same type of matrix that we have seen also on the Colab notebooks will be present also here. Then we can have alerts, or exactly what I mentioned. So we can define alerts for accuracy, for the validators, for different type of rules, contradictions, and all these parts. And this can be like set up and configured automatically from this UI. Then we have a usage report. In them, we can see exactly how much we have used the API per day and how many calls we have done based on a token based. And this is the section where we can grab the OpenAI key. So we are in the phase in them. We are trying to leveraging the LLM's hallucination, and by using Pythia, and why someone needs Pythia, it's like by error mitigation and in a way by trying to detect and to validate the RAG and LLM before sending information out. And there are like clear areas, and in them it's critical to have a system like that. And in a way, Pythia has its unique methodology of claim extraction, real-time monitoring, and the most important part is the knowledge graph integration. And that's it. Thank you for the time, and please try to sign up and see exactly how Pythia acts and check out Pythia.
And so now we'd like to turn it over to you to see what questions you have about Pythia. Yeah, so if you have any questions, you can ask them on LinkedIn. We'd like to know what you guys are interested in. Okay, so it looks like we have a first question. Do we need a knowledge graph? And if so, could you give any recommendations in creating a custom knowledge graph? So obviously you don't strictly need a knowledge graph for this one. We do have like one that we use for some domains. We do also work on a lot of knowledge graph stuff here at Wisecube. So you can talk to us about figuring that out. There are a couple like openly available knowledge graphs you might be able to use, like Wikidata, which we've made extensive use in our own work. So I would say like one thing we have to add, and maybe Alin can talk some more about it, is that we have a number of data sets that we can use as a benchmark, so we can test these data sets against your system and measure them with Pythia.
Yeah, I can answer that question. If Pythia can be integrated directly into RAG, so We validated that by trying to use LangChain and add the Pythia into a LangChain process, and to check external LLMs against Pythia, besides OpenAI and stuff. And yeah, it should be very easy to be integrated into the RAG by simply using also the direct Python SDK library.
So if by test, do you mean like how do we know that our methodology is actually capturing the performance? So, yeah, if you want to clarify that, but I'll go ahead and like assume that's what you meant. So we're actually working on a number of benchmarks for testing Pythia versus like other sort of methodology that's been discussed in research. That paper should be coming out, relatively shortly. But I think one of the best things about Pythia is that like it's not just about like a singular metric for correctness, even though that's like a big part of it. But we also have all these other validators, so you can like test for correctness and have all these other validators, and then you can make your system smarter by be able to respond to this feedback from Pythia.
Yeah. On the other questions, like how to get access to Pythia in order to be able to test it, it's very easy. So you can check it directly, as I shown you from the Python SDK, or directly from the app by simply sign up, getting an account, and use it directly from the web interface.
So yeah, if there's any more questions, we have like our contact information earlier in this webinar, and you can contact us through info@Wisecube. So thank you very much for attending.
Yeah. Thank you.